Thanks for joining this special joint webinar between Lithionics Battery and Morningstar. We'll be sending you a recording of this webcast tomorrow via email. And we've also included a copy of today's webinar slide deck and the Lithionics implementation guide. And those are in the handout section of your GoToWebinar pane, so you can go ahead and download them now. You're invited to text any questions into the chat section of your GoToWebinar pane, and we'll cover as many of those questions as time permits before we conclude the webinar. With that, let's go ahead and introduce today's speakers. Representing Lithionics Battery, we have Stephen Tartaglia, President and CEO. And from Morningstar, we have Jake Sherry, Applications Engineer. Lithionics Battery is part of the Morningstar Energy Storage Partner Program, which was developed to facilitate collaboration between Morningstar and battery companies to help establish recommended custom charge settings and other best practices to optimize system performance. And Jake, I'm going to hand off to you and Stephen to let us know a little bit about Morningstar and Lithionics and what our audience needs to know to help them in deploying these lithium batteries with Morningstar controllers.
All right, perfect. Thanks, Mark. Hope everyone can hear me okay. So just to give you a little bit of the background from the Morningstar side, for those of you unfamiliar with the brand, we've been around since 1993, sold a lot of products, over 4 million of those have been distributed into the field. One of the main characteristics that you will typically identify Morningstar is that we have the lowest failure rate in the industry. We really pride ourselves in that. Our products are sold in over 100 countries on several continents, and again, primarily intended for mission critical applications is where we tend to excel. Of course, our products are used in residential and rural electrification applications. One to mention in particular is a project that we recently concluded. It was a solar home system, rural electrification initiative for Peru, in which we delivered over 200,000 of these DC energy boxes to homes in rural mountain villages in Peru, and over 3,000 community centers we brought power to as well, all told serving electricity to over 1 million people in Peru that previously never had access to it. So very impactful application there. We're very proud of that accomplishment. We also have served many commercial applications and industrial as well, telecom, oil and gas, and security, to name a few, are sort of where the bread and butter is for Morningstar. And of course, solar applications and off-grid products are very popular in mobile, marine, agricultural, and other applications included there as well. We really pride ourselves in being the charging experts. We do have the widest and most diversified product line, which you'll see here on the next slide. So here you can see just an overview of Morningstar's product line. We have over 8 different product families, including 30 different models. Many of them are application specific for many of the applications I mentioned on the previous slide. Again, relative to others in the industry, we have the most breadth in our product portfolio of charge controllers. And again, having been in existence since 1993, going on to our 27th year soon, or it will be 27 years very soon in April, that we've been in existence. We bring a lot of experience in charging technology to the industry, and again, definitely something we pride ourselves in. As you can see here on this slide, this will highlight our products in a little bit more detail. We carry both PWM charge controllers as well as MPPTs, and I'll talk about those two types in the slides coming up. But you can see here, these are a range of controllers that would be programmable for lithium compatibility. That's what we're really focusing on today, showcasing Lithionics as our energy storage partner. And you'll find other products from Morningstar, including some inverters, hopefully soon to be more, and we have some accessory products as well that bring a lot of unique functionality to the overall system operation for off-grid systems primarily. So here, just to give a little bit of an overview on the primary component we are known for, that being the solar charge controller. In this instance, again, we are regulating the power from in photovoltaics. So again, power hitting the photons hitting the solar panels, causing a reaction. And again, this creates current flow to the controller. The controller then regulates the amperage and voltage dictated by the needed by the battery to continuously charge the battery, keep it from overcharging is one of our primary functions. But also we have the ability to control DC loads as well. So again, here you'll see a list of many of the types of DC loads that we can regulate, and we can provide low voltage disconnects and load management for those loads if they need to be turned on and off based on battery voltage or time of day. Those are all things we can do with our controller as well. It's really important that the right controller is selected for your application, and again, its primary function is to extend the battery life. If you choose the wrong controller, you're going to see that reflected in the life of your batteries, which is really the most costly investment in your overall system cost. So definitely not a decision you want to rush or take lightly. So if we look at this slide, very similar. Again, the previous one was for DC loads, where we had the integrated load circuit on our controller that would provide the low voltage disconnect or over discharging protection of the battery. In this example, you can do the same thing, but with AC loads. And again, this shows a depiction of our SureSign inverter, which is just our small 12-volt unit for, it's a 300-watt unit for 12-volt batteries. And again, just to power little, smaller AC load requirements for, critical backup needs. But again, those are all components that need to work well together in the system. And certainly Morningstar, provides a range of those components and has reliability to stand by. So certainly can talk more about that in the upcoming slides. Just to back up a little bit on the types of charge controllers, again, the two differentiating types are MPPT and PWM. MPPT stands for maximum power point tracking. They're really intended for areas where sunshine or sun availability is less predictable. It can be somewhat inconsistent depending on the time of day or the season, time of year. You're generally going to see most benefit from an MPPT controller in cold weather conditions because that's where the ability to support a higher voltage array really comes in handy, and you can use true DC to DC step-down conversion to preserve power and boost the actual current on the output. So you're taking higher voltage, lower current on the input side, and then through power conversion, it steps down to a lower voltage, that of the battery, and then actually boosts the output current. That's typically, again, where you'll see the most benefit in MPPT with high voltage arrays and in cold weather conditions, especially. Typically, when you're comparing PWM to MPPT, when you equate an overall advantage in terms of the amount of energy harvested, we usually say it can be, 10 to 15% is usually a good nominal reference point, but it can be higher if you're in, Canada and it's very cold, but you have plenty of solar insulation and the panels stay cool. You could see even more yield, up to 30%. It kind of depends on the conditions and the site specifications. So then the other type of controller is the PWM. And the PWM controllers, PWM stands for pulse width modulation. They're slightly older technology, but still very capable, especially in warmer weather conditions, temperate climates where, again, if you're located at the equator, you don't get much fluctuation or variation in the sun hours each day. It's fairly predictable. The PWM controllers work well, extremely reliable, and generally a lot more cost effective as well. And again, Morningstar uses a PWM algorithm that originally patented, and it's really constant charging. So it's not like it really is interrupting, on and off the output current to the battery. It's tapered, on a power curve, which is very nice, again, in order to maintain a high state of charge in the battery as much as possible, and again, maximize the amount of energy available for backup when needed. And again, I think we went over the charge controllers portion of Morningstar's product line that would be compatible with lithium and therefore are relevant to the discussion today are shown here. So a couple of the PWMs, the ProStar, the TriStar, and then we have the MPPTs, SunSaver MPPT, ProStar MPPT, and two variations of TriStar MPPT. This one is 150 volt, and then there is also a 600 volt rated input version as well. So basically the main focus of today really centers around the inquiries that Morningstar has been receiving for the past few years. We've done some analysis, and about 30% of the customer system inquiries are inquiring about some type of advanced energy storage with typically lithium as their preferred battery chemistry of choice in our common off-grid solar applications. Again, these would be residential, commercial, and industrial. And one of the things I think that they often reference as far as what appeals to them about lithium is the extended cycling capability and the partial state of charge benefits, which again, at the end of the day, especially for industrial customers, means minimizing the site visits required. Often they can be in remote locations that are very hard to get to, and also very costly to make a site visit, especially if it's one that could otherwise be prevented or avoided with extended cycle life. So they're very interested in lithium. The most common follow-up request from that is, okay, well, what do you recommend, and what are the charge settings for the batteries that you recommend? Well, that's really the impetus for the Energy Storage Partners program that Morningstar put together. Our primary objective is to make sure that we are able to provide that peace of mind to end users that the batteries we're recommending are compatible, and all of the interoperability has been well vetted by Morningstar in cooperation with the manufacturer themselves. And so again, this all leads to an easier system installation, hopefully more plug and play. And it's really, through our documentation, we really try to provide a true, overview of exactly what is needed for the installer in order to ensure optimal operation in accordance with, Morningstar's expectations and the battery partner as well. So we've partnered together and summarized our requirements and suggestions for optimal system design and performance. So with that said, I will go ahead and pass it over to Steve, who can go ahead and give you a little bit of background on Lithionics and what makes them a good energy storage partner for Morningstar. Steve, if you're there, take yourself off mute, and I will pass it over to you.
Well, I appreciate that. Thank you. And I apologize in advance for my voice. I just got my voice back this morning, so I normally don't sound like this. I'll do my best. If I cough, just excuse me. I'll do my best not to cough. So we have a mission statement. The mission statement from day one, 10 years or more ago, has always been, how do our products add value? How do we give our customers a competitive advantage? And the goal has always been to offer the widest range of stored energy solutions that are superior to lead acid batteries, but always with this priority. It's always been safety first. So as a company, we're privately funded, so you could say this is our money. We didn't take money from other people and then worry less about whether there was going to be a battery fire. The customers that we have are people that are putting these batteries on, say, Main Street at Disney World, or people are sleeping over the top of these batteries inside a motorhome or in a yacht. So safety first cannot be compromised. Today, we're only propagating iron phosphate just because it tends to be safer. And with the UL configuration, it's made safer with the UL protective functions that they require us to design in. And we deliver new age energy solutions that do pioneer new value propositions, new technologies. But the most important thing is that it becomes an enabling technology. People understand that lithium can do things that lead acid batteries cannot do. We just have to find a way to do that safely. And is there a value proposition? So let's go to the next slide. So what differentiates Lithionics battery is that we've been around since 2008. We are building our third factory. We're moving into yet another new factory next door. March 16th is the date. And so these are just the highlights. It's a very busy slide. This information is on our website in the section called Why Lithionics. But you really can't become a good company, and you can't offer valid warranties, and you can't vet these designs until you've been in business for a certain period of time. A lot of the competitors that we had that were around in, say, 2008 to 2010, they've gone Chapter 11. And we see companies coming in that are only 2 years old, only 3 years old. And most of our competitors have abdicated manufacture on U.S. soil. And our passion is to create USA jobs and to build as much of this product on the vertical integration as possible, having the least amount of foreign content that's possible. So the batteries are built here. We're now a 10-year-old company, and it's all about continuous improvement. It's about hitting some base hits or some home runs, and then it just becomes a continuous flow of base hits. And I think you'll see that as we go through the rest of the slides. So next slide. So we are the world's first and world's only UL listed battery at 12 volts and at 24 volts. Now, Underwriter Laboratory has multiple tests. You can see them listed from UL 157 up to UL 1973. But there's two pieces to this. There's a stationary piece and there's a motive piece. And there's a couple of companies that have passed the stationary UL test standards and testing methods at 48 volt. But actually nobody has passed what's called the motive side. So it's one thing to pass stationary, but then we start adding shock, vibration, crush. In total, the number of tests for the stationary and the motive is about 40 tests. And the reason why we invested in UL is because safety cannot be a sales pitch. It has to be something that is verifiable. And what UL is saying is, okay, there's a difference between being 90% safe or 95% safe or 99% safe and 100% safe. And the difference between being 99% safe and 100% safe to us is a mile. And so when we got UL about 2 years ago, I believe, we qualified for a multi-million-dollar product liability insurance policy. And what that does is it allows people to design lithium batteries into their applications with no fear. And by providing an insurance policy for the installers, for the end customers, even for a distributor, has been a great boost to our business, because people have to know that these batteries are safe. They might be powerful, but if they're not safe, it can damage your reputation. It can threaten your job if you were the guy that picked these batteries at a big corporation, and it can damage people's stock prices. And so UL is a way to say that we're going to do 40 tests to these batteries, and no matter what we do to these batteries, here's the 4 conditions of acceptability: no fire, no explosion, no release of toxic vapor, and no release of combustible vapor. So building a battery, if you're Tesla, going in a car is one thing, but people don't sleep in their car. And so everybody wants mobile power. They want diesel generator replacement, and they're looking for batteries that are acceptable to have their domain be a common place to humans, and where humans work and where humans sleep. Next slide. This is one of the most complex things that we've ever done, is try to explain how a battery that is more expensive can actually save you money. So the way you look at this is you say, if I have $100 to spend, I'm going to get 16 amp hours of lead. But if I have $100 to spend, I might only get 6 amp hours of lithium. So you have a higher initial investment, but when you count the cycle life into the batteries, and you move from, say, 800 cycles to 3,200 cycles, then you're actually replacing the lead acid batteries more frequently. And in some instances, the batteries might not even fit, because people seem to be demanding more and more power and more off-grid time, or more and more diesel generator runtime reductions, just because people are becoming more aware of idle mitigation and the fact that diesel particulate is clearly carcinogenic. So what this is saying is that lithium will always be upfront more expensive. However, over time, there's always a payback. If there was no payback, there would be no lithium. So the most important thing is to prove to customers that there is a value proposition. Now, people look at batteries 2 ways. That battery costs me money. I want to pay the least amount for that battery. Or that battery makes me money. And a lot of our customers are using these batteries to run commercial enterprises, or to get green tax credits, or to reduce their carbon footprint. every single professional corporation that we've worked with over the last 10 years has all proven that there's clearly a value proposition. And one thing I'll mention, we're getting ready to launch a new series of batteries where the cycle life has been moved from 3,000 to well over 5,000. It's a new carbide-based silicon separator that's going into the cells. So we're getting ready to about double our cycle life on the next generation of batteries that's coming out. So there's always a superior ROI, but for some people that just don't have CapEx, because let's face it, if the batteries are more expensive, it moves from OpEx or operating expenditure to CapEx. We do have a commercial leasing program. The fact that we've been in business now for 10 years and we have proven actuarials that we can show leasing companies, there is a company that will provide multi-year leasing so that our customers can move it out of CapEx and into OpEx. Next slide. Okay, so many, many years ago, people weren't talking about this. Solar really had to be subsidized to make it work. But there is a value proposition when you move away from wet cells to AGM or AGM to our batteries. Our batteries have such a low internal impedance. We have a significant reduction in impedance by way of so many different engineering facets. Like, for example, we don't use MOSFETs. We use a pure silver alloy contactor. And we use pure copper bus bars. We don't use aluminum bus bars. And so when you add up everything, it means that whatever's coming out of Morningstar's solar charge controllers, we're going to harvest 99% of that. With a wet cell battery, you're going to harvest about 60%, but now you have to consider round trip efficiency. So if we harvest or if we lose 1% on the charge side, on the discharge side, we lose another 1%. So now the round trip efficiency of a lithium battery made the way ours are is 98%. Now you have to take the wet cell battery, and when you're sizing your batteries, you have to consider depth of discharge. When you're sizing the solar panels, you have to take into account the round trip efficiency. So you're going to harvest about 60% into a wet cell battery, but now on discharge, it's 60%. So you have to take 0.6 times 0.6. And so in essence, with a wet cell battery, it's really 36% round trip energy efficient, where we're 98%. So what does that mean? Customers who change from lead acid to lithium are seeing reductions in their charge time by 2/3. So if before it took all day to charge the battery bank for nighttime, with our batteries, they're charged up by typically 11 o'clock in the morning. So you can either put a bigger battery bank in, or it gives you more solar load to power daytime loads if your loads are higher during the day. Or when you're doing your engineering, you can typically cut your solar panels by 50% on average. Next slide. Okay, so we'll get into the product a little bit. Our strongest asset is our battery management system. So we're the only company that we know of that owns our own microprocessor technology. The battery management system has to be a battery management system, but we turn it into what we call a PLC. It's a programmable logic controller. And what that means is that the BMS is bidirectional. It means that people can use our TCP/IP telemetry for controlling our batteries, reading our batteries, but also controlling our batteries over Wi-Fi networks for solar-powered off-grid cellular towers. People can monitor the state of health. In the app, you see that we have state of charge, but what you see up on the actual graphic in the palm of that person's hand is status and fault code reading. So our BMS broadcasts in RS-232, UART, TCP/IP, and CAN bus. Our diagnostics include battery life tracking, Bluetooth diagnostics, data logging, etc. But the main thing about our BMS is it's extremely versatile. Any BMS can run at any voltage. So we had a customer in yesterday. He said, "Hey, I've got this cellular network. Some are going to be 24 volt, some are going to be 48 volt. It doesn't matter. Any of our modules can be either series or parallel connected, and we produce about 100 different modules, but we can make about 3,000 different combinations of batteries. So we have customers that will stock, say, a 24V300, but they can make a 24V300, they can make a 48 volt battery, they can make a 96 volt battery just by changing the programming of one single external BMS. Next slide. And here we talk about our plug and play modularity. This has really been a wonderful thing, especially for installers. And we developed this thing called a combiner box. And so you have one external BMS for single point monitoring, and the external BMS is really superior because you have a 10-pound BMS. If lightning strikes and something happens to the BMS, then you can send the BMS back by overnight. We can fix it, send it out the same day, the next day. You can send the BMS back for firmware upgrades. Pretty soon we'll have bootloaders. We'll be able to do firmware upgrades in the field. Some people want different variants of CAN bus to interact with other consumables, whether it's a charging device or an alternator. But the main thing is the modules themselves. It took a bit of convincing to get UL to go along with an external BMS, but by separating mean time between failures of cells, which is very long, and then the potential for an inexpensive electronic component from, say, a capacitive event or some kind of a transient event or a lightning event, having that BMS be an external device makes it field serviceable. So some critical applications have a spare BMS. So in the picture you see, this is a battery system for boats that are operating in Texas. There's about 50 sightseeing boats that are commercially moving people around. And if one module goes down, an LED lights up, and you can just simply disconnect that one module in 1 minute, you're back up and running. So the key here is field serviceability, quick installations. You can put together a 50 kilowatt installation. You literally could connect this thing in 5 minutes and be up and running. The only challenge would be placement of the battery and getting it where you want it to go. But other than that, there's no tools required. Next slide. We're here showing actual applications. We don't just show a picture of SpaceX as if we didn't have that business. So we're powering, we're very large in the RV business, and all of these RVs are all moving towards heavy solar. The picture in the upper right is of former Vice President Joe Biden's home. That particular home was actually damaged in a hurricane a couple of years ago, and you'll see how that house was rebuilt. And the solar was actually moved off the roof and into some side panels, but that's a home that's on a remote island. And so the solar and the lithium was the only method, aside from having a backup generator. Automatic guided vehicles, that's the Raytheon Missile Systems factory. Our batteries are underneath live warheads, so safety was critical. A previous competitor's battery actually exploded underneath that warhead, missed the warhead, and put a hole in the roof of the Alabama factory. SpaceX, our batteries are used to safely load payload on a hoist system after the rocket propellants have been loaded. And then the boat on the right is a boat built in Latvia. It's the biggest trimaran boat built, and they're using our battery for either hotel load or electric propulsion. Next slide. So here's the rebuilt Joe Biden house. Now, he did sell the house. It's now owned by a private investment company. Here you see the solar panels are now moved off to the side. This is a home on an island off the coast of Naples, Florida. And we're using this is a 2016 application, so obviously we're showing Snyder. My apologies to Morningstar about that. But our batteries are actually put into, if you look at the left-hand side of the house, there's a laundry room. And they originally had lead-acid batteries in that wing, and the lead-acid batteries were causing the home foundationary pylons to sink. And so they brought us in to solve that problem. Next slide. And this is a picture of that laundry room. So the washer and dryer are right to the right-hand side of the wooden door. But here's the entire system. That's about 50 kilowatt hours of lithium-ion batteries. They haven't gone into a cabinet yet. But when you have underwriter laboratory approval, you really don't need metal cabinets. It means that your batteries can be qualified as being safe, even if it's on a wooden shelf. Next slide. So this is where we turn it back over to the folks at Morningstar. They'll talk about key characteristics that lithium needs, and they created this slide. So I won't mute just in case Jake or anybody has a question, but I'm going to let Jake take over now.
Sure. Thanks, Steve. All right. So, yeah, we just kind of summarized the what we have called the 8 lithium characteristics that can really have a big impact on the overall system behavior. So just want you to be aware of them. You know, if you're considering making the change from lead acid, these are some things you'll want to be aware of. One is the battery management system. Again, as Steve mentioned, it's an electronic system for balancing and protecting the cells, generally protecting against, you know, over voltage, over current, over temperature, are the primary things that they're monitoring on the cellular level. If a BMS isn't in the battery, you're definitely going to need one with your system. And we always urge people, you know, I know a lot of do-it-yourselfers out there are sort of building their own banks from recycled car batteries or something like that, and not deploying the battery management system that is really critical to keeping the operation safe. And so, again, for anything used with Morningstar products, and I believe Steve would always agree here that a battery management system is really the core of what is important in keeping the overall operation of the system, you know, functioning the way you want it, and, you know, with safety as a primary factor of importance. So I think battery management system is number one. Number two is that there is a narrower voltage range. What I mean by that is that there's really, if you look at, you know, the range of voltages, the voltage fluctuation of a lithium battery throughout its varying states of charge, it's pretty flat until the very end, you know, when it may just fall off a cliff. But again, there's really that resiliency of the voltage is very tight. So it keeps within a fairly narrow window. You don't have quite the swings that you do with lead acid. And again, so one of the things I recommend, you know, being aware of, and again, in this case with Lithionics, you know, Steve has a lot of built-in capabilities for monitoring state of charge, including, you know, the Bluetooth mobile app, and other external meters and gauges, so forth. You'll definitely want to have one of those, because using voltage as an indication of state of charge is not accurate for lithium batteries the way it can be more accurate with lead acid. Cold temperature charging is one thing that I like to mention as well. In particular, just as it differs from lead acid. There is a little bit more sensitivity, I would say, or prevention from cold charging in cold temperatures. A lot of times the BMS will monitor for those conditions and keep not allow external sources to flow energy into the battery if the temperature is too cold outside, because again the retention there is not optimal and in many cases can be damaging or dangerous to continue. So you want to make sure that you keep the temperature conditions at site in mind when you're specifying a lithium battery. We do have, again, one of the unique features I'll talk about with Morningstar in the upcoming slide is the ability to fold back the charging current for cold temperature conditions. We call it, low temperature fold back. And so I'll show you how that will be useful for certain applications with lithium batteries in particular. But it's good to know that Steve as well, Lithionics offers I believe you offer a cold temperature charging kit, an accessory that you can use with the external BMS. And
yes.
I guess, Steve, I don't know if you want to talk to it briefly, but it was my understanding, I think that could enable charging down to like -20. Is that correct?
We've tested to -20 Celsius, -4 Fahrenheit, because our in-house freezer only goes down to -20 Celsius. But in an 8 kilowatt module, we've got a very unique convecting system that only consumes 30 watts continuous, clearly a load that can be managed by solar. So we do have batteries that are operating in Alaska, Colorado, up in Canada. And I do want to say one thing. This is a fantastic slide. I mean, Morningstar did a great job on this. If you buy a battery that allows you to charge below freezing, you will get micro gas bubble formation, and UL considers that to be not only a shortening of life, but damaging to the battery. And so don't buy a BMS unless it absolutely stops the charging below freezing. But the key thing is that if you're below freezing, the whole BMS is going to shut down. So we manufacture a dual channel battery management system where solar can be on the charge channel. And if it's mission critical, your loads, because you can always discharge down to -4 with no heater kit. So we can selectively cycle and control the solar charge controllers by way of our dual channel, dual contactor BMS. But the critical thing is, about 7 years ago, we did develop this amazingly efficient internal heater kit, and it doesn't cost a lot of money. So we've got that problem solved too.
Excellent. Thanks, Steve. I think that's a really good point to highlight. And the part about the dual channel BMS, to separate the operation of charging and discharging, holding them subject to different constraints in terms of temperature tolerance, because many of the lithium battery manufacturers will say, okay, well, you can only charge it down to 0 degrees Celsius, but you can continue discharging down to -20. So again, Lithionics has a great solution in terms of enabling that to prioritize load functionality in cold weather conditions. So again, just picking up where we left off, I think on number 4, the full discharging capability. You still don't want to, again, some manufacturers will say, discharge the battery 100% till it, hits the floor and it's totally dried up inside. I would say, again, that's still not recommended. Steve, I don't know if you have a specific state of charge threshold that you limit discharging below, if it's 80% depth of discharge for optimal cycle life, or you may have more information about that. But I know, it does vary a little bit from manufacturer to manufacturer.
Yeah, I mean, with NMC, it's that they don't want you to go below 10%. That is damaging. With iron phosphate, absolutely, you can go from 100% down to 1%. So what we call the NeverDie feature is a user programmable feature on the BMS. There's 2 low voltage disconnects, and we're the only company that I know of that has this. But we will automatically stop discharging at 10%, just in case you have, let's say, an electric vehicle and it's an electric boat and you're 25 feet from the dock. You want to have that spare 10%, and that's called the NeverDie power reserve. So we're always going to shut off discharging at 10% remaining, but then you press a button and then you can access the last 10%. And there's some reasons that we have that, but no, we do allow 100% depth of discharge to get 2,200 cycles. But if you say go down to the NeverDie power reserve of 10%, you're going to get, say, 3,000 cycles. So yes, the customer can choose to bookend his state of charge discharge level, and then greatly impact life.
Yeah, that's very good to note. Thanks, Steve, for clarifying. And also, one other important attribute is the low self-discharge. Again, this is very different from lead-acid batteries. They're very comfortable in, again, being left on the shelf for extended periods of time, just at rest, not connected to any charging sources, much longer lifespan at that point than lead acid. And again, if you're talking about extended float or standby periods, that's perfectly fine. They don't have to. You can keep them connected to a trickle charger, for extended float operation. But again, you'll see with Morningstar, we have the ability to allow the controller to transition back to bulk charging after a certain amount of time if you time out of float. And again, by controlling this time window of how long or when to dictate when the charge controller will re-enter the bulk state, you make sure you're not always exercising lithium batteries at too high a state of charge. And that relates to number 8 on this list, the controlled absorption charge. I'll get to that in just a second. The high charge and discharge rate, again, very different from other chemistries. In particular, with lead acid, depends on the type, the chemistry and subtype. But if you're talking about the charge rates, generally I haven't seen anything higher than like 30% of the C20 amp hour rating for lead acid usually is the max charge rate. And for your batteries, Steve, is it 1C? Is it the C rate of the battery itself?
Yes. So we have 3 different levels. We have 1/2 C, which is 2-hour recharge time. We have 1C, which is a 1-hour recharge time. But we're just now launching our new series of high charge rate power cells, and those are easily a 3C, which really would be, say, 20 minutes. If you've got the infrastructure to rapidly charge the batteries, and most people don't have that infrastructure, but with combined solar, inverters, on-grid type of charging, it is possible to charge our batteries in 20 minutes.
Wow, that is impressive. So that's certainly an important attribute to highlight. The charge rate will be different than other chemistries you may be used to. Typically, again, what I've seen, like Steve alluded to, the C/2 rating, nominal rating seems to be, the 2-hour charge rate seems to be sort of somewhat of the industry standard. But again, there's a lot of variation in terms of higher capacity charging capabilities, whether it's for a limited period of time or if it's a special variation of that chemistry that allows higher charge rates continuously. So that's good to know as well. And of course, as Steve mentioned, the higher upfront cost, but again, it's really about evaluating the cost over the lifetime of the system. And generally, you're going to get a much longer lifetime with lithium batteries, much higher cycle life, which again means that you have to convey that in a way for users to understand, other than just the capital expenditure. As Steve mentioned, converting that into an operating expenditure is a valuable way to do that. And again, just finishing up on the controlled absorption charge, Steve mentioned this to me when we were outlining the settings for our integration guide, and this is one that I thought was very important, and I'm glad they mentioned it to me. Lithium batteries really don't like the extended absorption times that you use on lead acid batteries. I mean, lead acid you can keep in absorption for as long as the day is long, and it's not going to harm it. But the importance of titrating the absorption time and limiting that so that you are able to just do a little bit of top balancing, but not keep it at that elevated state for too long is important. And the dictation of when you would drop to float after absorption, do you stay in float indefinitely, or if there's additional solar available, can you switch back over to bulk charging? And I explained to Steve that we do have a setting called exit float, or float timeout, where we can precisely control the amount of time that the controller remains in float before it triggers a rebulk. So this is good so that you're not cycling the battery excessively, if you don't need to. If you're just doing it based on voltage and the battery drops to 13.2 and you immediately go back to rebulk, well then again you may be keeping the battery at an unnecessarily high voltage for too long, and you can risk damaging or shortening the lifetime of the battery. So that was one thing that he said Morningstar really got right, and appreciate the feedback, Steve. So just to continue on here, the rest of the presentation goes fairly quickly, but just wanted to highlight a few unique features and capabilities of Morningstar controllers. The one we have pictured here is our ProStar MPPT, which is one of the newer models, offers a lot of sophistication. The one feature that I mentioned previously, just briefly, was the low temperature foldback. And again, this can be a useful feature. What it does is it allows the user to specify a temperature derate range. So, a threshold between high and low temperature values where that will instruct the controller to linearly derate the charging current, so that if you're at any point in between, you're at a proportion of that amount of current available. So again, for instance, for many batteries that maybe don't have the dual channel capability to control both load and charging independently, you may want, most manufacturers will say don't charge lithium below 0 degrees Celsius. And so if there is, perhaps they give more information or some temperature curves on their data sheet that show, oh, okay, well, you can charge it at this rate as you go below 10 degrees Celsius. And then, by the time you get to 0 degrees Celsius, all charging should stop. So instead of just cutting it off at, all of a sudden at 1 degrees or whatever it is, you can get a nice approximation for that curve with a linear derate. So you can still maximize the amount of energy harvested into the battery as temperatures continue to get colder. but without risking, doing any damage to the battery, so that it's still completely cut off at that low threshold. So it's very useful. Again, what you see here, you'll see on the ProStar MPPT, we have the option for an interactive meter display. This is great just to be able to program, make quick settings changes on the fly. If you're in the field, you're on site, you don't have access to your laptop or any kind of communication adapter to connect to your PC. You just do it right on the meter display, and it allows you to customize pretty much all of the settings to a pretty advanced level. So having that capability is very nice. Additional functionality is the ability to use the RTS disconnect, since you don't really need the RTS for lithium. Again, your temperature coefficient is going to be set to 0 anyway, but allowing you to use the remote temperature sensor terminals on the controller as sort of a way to trigger a remote on-off of the controller, and that may be controlled by the BMS itself through a contactor or built-in relay switch that can again just open or close that circuit, so that to have a little external control of any external charging sources. So the BMS can say, well, if it's getting to a low state of charge warning, and it wants to give the controller a heads up when to turn off the PV array, essentially to stop charging, that can be a useful contact for signaling purposes to do so. Also, the controller is programmable via USB, so even if you get the option, you get the version of the controller without the built-in meter display, it does have an RJ11 communication port, which can be converted into USB using our UMC1 adapter, which you can find out more information on our website. That's a good tool to have if you're planning on replicating settings between multiple controllers, and definitely an accessory that you would need for many of our controllers to upload the MSView configuration files that we'll talk about in just a second. And then lastly, the one other defining attribute of Morningstar controllers that you'll typically find is the voltage sense, remote voltage sense capabilities. So we, again, in addition to measuring the battery voltage at the at the output terminals for the controller, we also measure battery voltage directly at the battery through some small, sense leads connected to the battery terminals, and that again will give you the proper compensation for any voltage drop in the wiring, which can be again a very useful feature to have for improving the accuracy of the overall regulation.
Jake, I just want to say, I wish every device had that. We really struggle with devices that are out there that do not have that remote voltage sense wire, because the cable lengths really do have an impact on the charge efficiency of lithium. So I just want to maximize how important that really is.
Yeah, I appreciate that, Steve. I think that's a really good thing to mention. Again, the voltage drop in the wiring can be significant, and this is not something that all of our competitors have chosen to provide, but we stand by it. So as it has many benefits, so we certainly urge you to use that if you have it available. So just showing you here, this is just a depiction of sort of what I was talking about with the low temperature fold back feature on the ProStar MPPT, and it's also on the 3rd generation ProStar PWM controller that we offer as well. But you can see again, depending on the information provided by the battery manufacturer, you may have some temperature derate curve provided, and within the software control on those Morningstar controllers, you can actually specify and get a nice approximation for the a linear D rate on that curve. And so you can still maximize, instead of just turning the charging off completely, you can just reduce it up to the point where it needs to be cut off completely at the low temperature threshold, but still maximize the low temperature performance and harvesting capability of lithium batteries in cold temperatures. And these are just a few other of the custom charge settings available, for sort of what we call special use cases. But high voltage disconnect is one. This would be on the load side. And again, as I mentioned earlier in the presentation, many of our controllers have integrated load circuits and the ability to regulate and protect that load. So one of the key pieces of that protection is the high voltage disconnect setting, which again can remove power to the load, if the battery voltage gets too high, because again, you don't want to damage sensitive loads that have to operate within a tighter voltage spectrum. So again, that is one additional capability that I think is important. Max regulation voltage is another one, although we don't particularly use it in this case with lithium batteries because there's no temperature compensation to begin with. But this would provide a fixed ceiling or a fixed voltage limit for the maximum output you can ever get from the battery, basically. So, if you don't want to have the battery regulating above 15 volts, you can fix it there so that even with temperature compensation on your highest absorption setting, it's not going to exceed that and therefore prevent damage to the load, which is also fed from that battery voltage. So those are sort of two ways of providing protection to both the load and the battery. Absorption extension is another one, although more useful for lead acid types, really, where that enables, when you have those memory effects, which you don't have with lithium, but with lead acid, if you have the memory effects based on depth of discharge, you may want to, or you may need to extend the absorption time the following day or the following charge cycle to recover that lost capacity. So you have to keep it in absorption longer. And we have a setting through our custom settings in MSView or via the meter display that allows you to adjust that accordingly. It can be useful. And then the temperature compensation variations, again, it's fully custom programmable. In this case, for lithium, it's just going to be set to 0 as it does not require temperature compensation. But for other battery chemistries, you can certainly dial that in as much as needed through custom programming. So just to go through real quick, this is just a example of what we have done through the Energy Storage Partner Program in cooperation with Lithionics and other battery brands as well. We've gone through the process of generating documentation, which you can find on our website. You just go to the Resources tab and click on the Energy Storage Partner Program. You'll see a list of all the brands that are included in our ESP program, and you go ahead and click the check boxes of the ones you want to download the PDF of the integration guide for, and then just fill out a few additional information fields and then click submit. When you open the document, you'll see that all of the settings are summarized in terms of a nice battery overview. You get the critical settings, you get some additional optional or recommended settings that would be included, and then everything would be rolled up into a pre-configured downloadable zip file or zip folder that you can export from a link in the integration guide. So I'll just show you that on the next slide here. So this is inside the integration guide for Lithionic. For example, you will need our MSView software to program the unit if you want to utilize the MSView, the pre-configured files that we put together, which takes a lot of the hassle out of manually inputting all the settings and allows you to just simply upload them to your controller and off you go. So right here is the link for the config file zip folder, which has all of the configured setup wizard files for each controller that is compatible with that battery manufacturer. And you'll see that. We'll just go through a quick example on the next slide. But basically what you'll do once you click on that link, you'll get the zip folder, Lithionics MSView configuration files, and you'll go ahead and just click the extract all. And then you'll have to browse for a destination. You can save it to your desktop or your downloads folder, and then just click extract. And then what you want to do is, again, get our MSView software. There is a link to the MSView software in the integration guide, but you can also access it through our products drop down from our main website. And you can just go to the MSView tab and click on that icon. And then you'll see just a brief little description and including a hyperlink text here saying click here. Go ahead and just click on that, and that will initiate the download. So then once you've downloaded and installed MSView, you can go ahead and execute the file, open it up, and the first thing you want to do is go to the Devices tab and go to Search for Connected Devices. And again, of course, this assumes you've already made a successful hardwired connection to the controller. When you click on the Search for Connected Devices, it should automatically detect anything that is connected, whether it's via serial or IP. So just highlight the controller that you are connected to and go ahead and click connect. So once you do that, you should see the controller pop up in the left-hand sidebar here, and you should see the icon turn green when you have physically connected to it. And then you will go ahead and go to the Tools menu, which has, again, the list of all of the setup wizards contained in MSView. Again, they're defined by product, so you have to go to the appropriate setup wizard for the product that you are connected to. In this case, it's the TriStar MPPT, so you go ahead and just open that. This is what the window will look like. The first thing you'll do is you will click on the Read from File button, and you will be able to, again, locate the files that you previously downloaded from the MSView configuration files link in the integration guide. So that was the zip folder full of all of the Lithionics configuration files. And so you go ahead and select the file for your device. Again, one thing to be aware of for Lithionics is that they do have 12, 24, 48, and 51 volt offerings in terms of the nominal battery voltages. And so Morningstar, again, supports 12, 24, 48 volt batteries in a sort of general sense. You just want to make sure, again, since there are two voltages that have slightly different cell counts between, in the vicinity of 48 volts, whether it's 15 in series or 16 in series, you just want to make sure you select the correct config file for that particular battery. So if it's if it's not, if it doesn't indicate the 15S, then it's assumed to be 51 volt nominal, which would be 16 cells in series. So that would be the one you would want to select. Otherwise, use the 48 volt 15S, which has an adjusted config file. All right. So when you go ahead and upload that to the setup window, again, one additional, you may want to make some additional changes if it's very application specific. For instance, if you need any kind of like lighting control setup, you can do that. Go back into the setup wizard for the TriStar MPPT, and you can customize any settings needed there. Here would be where you would put the low temperature D rate if you do need that. And then once everything looks good to you, you go ahead and just finish the setup wizard. It'll, again, populate all of the settings here. So you can do a last minute check and just scroll down the sidebar there, make sure everything looks good. And then you'll go ahead and just click on the Program TriStar MPPT button. And then it will take you through just a pop-up window will come up just with prompts to tell you when to cycle power to the controller because you've uploaded custom settings. You go ahead and just give it a quick power cycle, and then once you do that, the controller reboots and you're back up and running with the proper settings. So again, that shows you how easy and straightforward it is as far as utilizing the custom settings we put together with Lithionics and other battery brands included. The config files are there for your use, and we certainly encourage you to use them and provide any feedback that you see fit. Just to kind of wrap up and summarize what we've talked about today, when you're talking about differences between battery technologies, whether it's lithium or lead acid or anything, key differentiating factors are the expected lifespan, so your cycle count. Your maintenance requirements are a big one. Again, I mentioned that many of our remote customers too have demonstrated interest in lithium because it's less site visits they have to do. If everything lasts longer, the system uptime is preserved, and nothing occurs that requires their attention or intervention, then more power to them, and that allows them to capitalize on the operating expenditure. And then, of course, your space and budget. Those are all things, depending on the application, that you need to keep in mind to see, what is the right fit for you. And in any case, you just want to make sure that you get the proper charging guidelines for that specific battery. Don't use general settings just because they're not a tailor fit to each individual battery. You really want to use custom settings and work. And again, Morningstar has saved you a lot of time here working with the battery manufacturers directly to outline the requirements and their setting recommendations. And so we've collected all that data for you in an easy to digest format, and hopefully will save you some time on site as well. Try to make the system more plug and play. We've shown you, again, our charge controller settings can be adjusted really easily using our MSView software. Or again, you can, if you're using one of the newer controllers that does have interactive meter displays, you have that convenience of doing so very easily in the field. So that gives you, I think we kind of covered a lot of ground. You got a good overview. What else would you like to know? I think it's time for Q&A. So with that, I think I will go ahead and turn it back over to Mark McHenry, who can go ahead and read off some of the questions that came in. Mark, are you there?
I'm here, and thanks very much. Thanks very much, Jake, and thanks very much, Steve. We had a really good audience here today, and we did have some questions that came in. So let me just address the first one to Jake. A question from Howard coming in says, Does the charge controller eliminate the need for compatibility between the solar panel and the batteries?
Yeah, so generally, with modern charge controllers, you never want to connect a PV array directly to a battery. The charging is completely unregulated then. So you do need some form of regulation to prevent the battery from being overcharged, to monitor the battery status, and so forth. So in any case, yeah, the charge controller would take care of that, whether it's PWM or MPPT. And especially, when you're dealing with higher voltage arrays, when you're talking about a high voltage potential directly connected to a battery in a closed circuit, that could be potentially damaging to the battery. So you certainly don't want to do that. You should always have a charge controller as the intermediary device regulating the charge current from the PV array to the battery.
Okay, terrific. Let me just take the next question because a couple of people asked, how do we receive our NABCEP credits for this, for attending this webinar? And you will receive an email within several days. It'll probably be early next week. And your cert will come in the form of a NABCEP cert email. So thank you. Those of you in North America, which is most people on here today. Okay, so great question there. Okay, I have another question coming in here. Temperature related question. So I think this one I'll address to Steve. The question is, I have an off-grid telecom site just outside of Phoenix. Temperatures can reach 115 degrees in the shade. How do your batteries perform in these conditions?
So Underwriter Laboratories prevents us from allowing a charge above 114. So the main thing is there is a special insulation system that we've developed with a supplier. It's actually used in the Chevy Corvette to keep heat out of the compartment. It's a low K value insulation material. As long as the battery is not in direct sun and we keep that battery at 114 and below, yes, you can operate in those kinds of conditions. Now, the battery management system is programmable by the user to change the maximum temperature limit. I mean, you can discharge up to 131. The key here is how do you charge above 114? For many, many years before we had UL, we allowed charging up to 121 and never noticed a shortening of life. But UL is very strict and they want you to have some design margin. We do have customers that will just reprogram the BMS. We give you the secret setting, and then you can go up to 121. And you might get shorter battery life, but if a battery is going to last 4 times longer than what you have right now, for most people, shortening up the battery life a little bit is acceptable.
Okay, great. Thanks for that answer. Another question for Steve. What is the minimum battery temperature range for your batteries?
Well, charging, the minimum would be 32 freezing. So every single lithium chemistry, until we go to solid state electrolyte, which is coming, but it's probably a year away, they're all basically a gel-based electrolyte. And so if you freeze the electrolyte in between the laminations, you get micro gas bubble formation when you try to charge below freezing. So freezing 32 up to 114. Again, if you charge below 32, you're going to shorten your life because those micro gas bubbles force a delamination to take place. So really, you want to put our cold weather kit in. Most of our batteries have this super high efficiency 30 watt per hour heat convection kit that's built in. So there's really not a big penalty for maintaining the batteries. So the way that kit works is that inside temperature of the battery reaches 35, heater kit comes on, we warm it up to 40, and then we turn it off with a thermostat.
Okay, terrific. Good information there. See a question here coming in. And by the way, some of these, I don't know if everyone's going to know the answer to all these questions, so we can certainly take them offline if need be. But let's take a look at this one. It says, this one's for Steve. Question is, does UL mean that we can install these batteries in the residential basement in Canada?
Yes, we also have CSA. So we have Canadian certification. So UL 1973 is what's called a built standard, something that's built, and that can be a building, an RV, a yacht. This standard is a standard that certifies that these batteries can go in a living space. So again, no matter what UL does, no fire, no explosion, no release of toxic vapors, no release of combustible vapors. Those are the four things that they're certifying. So the answer is absolutely yes.
Okay, thanks for that question. Thanks for the answer. We shift back over to Jake. We have a charge controller question in. So question is, doesn't the battery BMS fully control the charging of the battery, thus negating any need for a controller from Morningstar?
Jake, do you want me to take that one?
You can if you want.
You start. No,
well, yeah,
you're happy to start.
Okay, I'll start just by saying, yeah, we still need, the battery management system again can, regulates mostly as a protection function, but in terms of current regulation to the battery and power conversion from the solar panel, that needs to be done on the controller side, especially with MPPT controllers, because you're dealing with higher voltage input, and you need to be able to do successful buck conversion, which is step down DC to DC, high voltage to low voltage, to provide proper output to the battery. So yes, very much the charge controller still needs to be a part of it. I don't believe, unless I'm misunderstanding, that the BMS can do it all. Is that correct, Steve?
No BMS can do that, and I'll tell you why. Because first of all, if somebody could invent a constant voltage power supply to work on lithium, that person would be very wealthy. So unfortunately, you need, even with a lead acid battery, you need multi-stage charging. And it's a great question, by the way, because people say, well, why can't I just use a simple converter, a simple power supply? And the reason why is that once a lithium battery is fully charged, it has to be permitted to reach its resting voltage. So you'll charge a lithium battery to, say, 14.6, but the natural resting voltage within 2 hours is 13.4. If a charge controller doesn't have that restricted absorb time, let's say 30 minutes, then you're taking a full battery and you're trying to shove more voltage in. So what happens is, the way lithium works is you're building what's called polyanionic shell orbits around the lithium atom. And you can continue to build more and more shell orbits, but sooner or later you're going to get expansion, delamination, shorter battery life, and sooner or later you're going to cook the battery. And so these solar charge controllers are very critical to the life of the batteries.
Okay, great question.
Yeah, I agree with you. Thanks, Steve.
Let's see, we have another one coming in here for Steve. What is the largest Lithionic battery?
So we have a 51 volt, 16 kilowatt hour battery in UL right now. Up until this point, our biggest battery was an 8 kilowatt that got through UL. We're almost done with 16 kilowatt hours at 51 volts. But you can take and use, say, our 6-port combiner box. So a 6-port combiner box can have 6 batteries in parallel connection. And so I wish I could do the math, but I'm not that good. You could take 6 modules on one BMS times 16, and you're at 96 kilowatt hours. Where you get into trouble with lithium is when your discharge rates get to be very high on a 48-volt system, you develop a lot of ripple current. And that can be damaging to inverters. And that's the reason why, if you are discharging at very high rates, let's say your discharge rate is 51 times, say, 300 per BMS, you have a 15 kilowatt discharge rate, there's a limit for how much higher you want to go before you jump to the higher voltage. But for most applications, it's not a problem if your discharge rates are controlled. 6 modules would be 96 kilowatts. You can run those in multiple parallel. So you can have another BMS, another 6-port combiner box, and another 96 kilowatts worth of batteries. So a sweet spot for our batteries right now in residential homes that are operating, let's say, on the Baja Peninsula down in Mexico, these people are typically putting in 100 to 200,000 watt hours.
Okay, very good. Thanks for that question. And again, thanks for that answer. Let's see, another question coming in here from Roger. What is the relationship between number of cycles and depth of discharge?
Wow, that's huge. So if you do a 100% depth of discharge with the current GT series, you're going to get 2,200 cycles until you reach 80% SOIC, or state of initial capacity. It doesn't mean the battery is unusable. So if you started with 100 amp hours and you do a 100% depth of discharge, then you're going to lose 20% of your capacity by the 2200 cycle. But we have customers that easily discharge down to 70% SOIC. But now let's say that you have solar and you're microcycling, and let's say that you're only doing a 50% depth of discharge. You're talking 10,000 cycles at that point. So depth of discharge, solar, and cycle life are all highly intertwined.
Okay, another question coming in. Could you tell us more about solid-state lithium batteries and why they are so important?
So there's 3 chemistries. There's nickel cobalt aluminum, which is a gel electrolyte used by Tesla, highly flammable. As we all know, we see it in the news. Then the second chemistry, which is being propagated in very high volume by the rest of the automotive industry, is NMC, nickel manganese cobalt. These are synthesized covalent oxygen bonds in what's called a nickelate chemistry. And when you break that bond, the thermal runaway condition is very harsh. And it's all about electrolyte ignition. So we're actually working with USA companies to bring this technology back into this country. Solid-state electrolyte allows us to use lower cost nickelate-based chemistries, which normally require water cooling and normally should not be put into a residential situation. Iron phosphate is always good for residential, but going to solid-state electrolyte is really looked upon as like the holy grail. It's going to take dangerous chemistries and make them safe. It's going to take dangerous chemistries and have them last longer. We're hoping to see the first solid-state electrolytes coming on stream. Hopefully, we hear that the bankrupt A123 facility, which is now controlled by the Chinese were getting ready to shut this facility down up in Michigan. Now private investors are looking at rejuvenating that facility. It's in the news. This is all public information, and going solid-state electrolyte. So that's going to be like the next wave. But iron phosphate is already reaching 5,000 full depth of discharge cycles. So I think iron phosphate will stay ahead of the pack, but the solid-state electrolyte will allow for some shorter cycle life and some cost reductions.
Okay, we have a few questions coming in about how people can purchase Lithionics batteries, and they relate to, can people purchase them directly or do they purchase through a distributor? We have somebody from a couple people from southwestern United States, and then we have somebody here from Costa Rica. So how would they go about purchasing your batteries?
Yeah, so the example in Southwestern, we have a dealer called Northern Arizona Wind and Sun, fantastic systems integrator. Go to the website, go to where to buy, and then look up and see if you have a dealer distributor in your area. We're also signing up installers to become wholesale purchasers. So we'll be attending the NADCAP show by the invitation of Morningstar. Thank you for that. And Roger Berry and Phil Silberhorn from our company will be there to talk to see if we can get some installers to become both wholesale buyers and systems integrators. So hopefully that answers the question.
I think so. Very good. I think we have time for one more question. And let's see, do we have to be concerned with any substances, like white substances that sometimes gather on the terminals and require wire brushing to remove with the lithium batteries?
No. So the connectors that are UL listed are silver-plated pin and socket that we in turn coat with a dielectric lithium grease, and it's used in marine applications. It really should be maintenance-free. Maybe every few years, if you've got a high salt air content, you might just want to buy some it's WD-40 makes it, just buy it on Amazon and just spray some dielectric lithium coating inside. But other than that, there are no terminals. They're all pin and socket shrouded connectors.
Okay, terrific. You know what? One more quick question. I think there's some we're not going to be able to get to, but this is the last one. We do have a question. Rolando asks, are there any restrictions regarding transport of these batteries overseas? Is any special packing required?
No, there is special packaging that we have, but we are certified to ship our batteries worldwide. In fact, we were the first company to export to China about 4 years ago, and we're still exporting to China. We do have some private carriers that airship our batteries because of our UL listing and our product liability insurance policy. So if you go to info@lithionicsbattery.com, and I think Jake has that listed, give me your location, and then I'll send you the website. So there's a website called FedEx Dangerous Goods Countries Served. If you just Google that, FedEx Dangerous Goods Countries Served, it will tell you a whole list of country by country if DG, dangerous goods, and unfortunately all lithium is categorized as dangerous goods, and so are lead acid batteries, but that will tell you where we deliver by FedEx.
All right, terrific. So with that, looks like we've hit the end of our time limit. I have the thank you slide up here. Leave it up here for a few more seconds if you need to jot down the phone or email info for either Lithionics or Morningstar. Thanks, Jake. Thanks, Steve, for being with us. A lot of great questions, so thank you for our audience. We'll see you next time. I'm going to conclude the broadcast, and Jake, if you want to close things out, thank you very much.
All right, thanks everyone. See you next time.
Bye now.